Hello, in this particular demo we're going to have a look at how we can create a canvas object that we can draw our game to. In this case we're just going to be drawing a bunch of bitmaps to represent us building up the level. It's important for us to be able to do this. In essence, the game is going to be a region of the screen that we will be drawing to frequently, and every single time we draw to it we will be likely drawing a whole bunch of different types of bitmaps. We'll have some for the background, we'll have some for foreground objects, for the player, for UI elements on top, and by drawing that collection of bitmaps we'll build up our particular scene, and in essence that's fundamentally how we render the world, and we'll do that once per frame. Now, to do this, what we need is a surface. Something that we can get access to, onto which we can draw all of our different bitmaps. And we need to be able to make sure we can do that 30, 40, 50 times a second. We'll also have an explore about how we can do that as fast as possible. And there's different options that are available within Android for doing this, and they differ in terms of their complexity. The standard way of doing it, and the one we'll look at first of all, was known as using a SurfaceView. So I can run my SurfaceView test here, which will just fire up. And what we are displaying on the screen here is 1,000 images, scaled different size randomly, every single frame, and we're counting up the frames as we go along. So, you know, this sort of represents us actually building up a fairly complex scene. There's actually a massive amount of overdraw on this that we'd want to avoid within a game. But nonetheless, here we are drawing 1,000 images at random, and we're doing that, in this case, as fast as we possibly can do it. And you can see the frames counting up around frame 120 at the minute. So for a surface view, it's the standard way of doing this, but it's not a particularly fast way of doing it. The surface that we get here doesn't currently within Android avail of hardware acceleration, so we're using our CPU to effectively draw to that surface. So it's good, but maybe not good enough. Within Android, if we, or the general recommended sort of words of wisdom or advice, is that if you do want to draw graphics fast, you have to get into hardware acceleration, and OpenGL ES is the particular rendering framework that you can use within Android if you do want to do a 3D or a 2D game and to make full use of hardware acceleration. OpenGL ES is lovely. It's possibly the type of thing you would want to explore later on by way of one of your sprints in terms of how you might introduce that into it. But compared to a surface view, it's very much more difficult. Surface view is very straightforward. We get a canvas, we can draw to that canvas, as we'll see. If we're using OpenGL, there's a lot of additional things we have to get into, and fundamentally it assumes a 3D world. So for rendering a 2D game, we've got to sort of tweak things slightly. We'll also, as part of this demo, have a look at a halfway house. There is a way of using a canvas object, so a nice simple interface, but getting it to be drawn in a hardware accelerated way, and I'll show you. So I'll show you a demo here. So this is getting the CPU to draw it, drawing 1,000 frames out, and we'll have a look then at how we can trick effectively the hardware in to do it. Now, it doesn't run particularly well within the emulator because it tends to actually crash the emulator in terms of running too fast, but it should learn perfectly fine in a normal device. And you can compare the number of frames we have going here to the number of frames that we had when we were using CPU acceleration. So getting the GPU to handle our draw requests will make our game run very, very much faster. So that's what we want to try to achieve. Let's have a look at how we can do this. Now we'll start off first of all looking at the basic render surface. And to do this, the two classes we are interested is in our demos.graphics is the SurfaceView test and the SurfaceView test fragment. As usual, the actual activity is just a placeholder for the fragment where all of the interesting stuff happens. So if we have a look at the fragment, it's a medium length class. there's a reasonable number of things that are happening within this. We want to go through and just to see what we have. Now this is our fragment. Within this we are creating one component or one UI element. So this fragment will contain a single element, and that element is going to happen to be a SurfaceView object. And we've got a SurfaceView renderer here is what we're going to use to draw to that SurfaceView. So we'll see that class later on down. When we create the SurfaceView, we're not specifying this through any XML view. We're creating a new SurfaceView renderer, which is a type of SurfaceView, and simply returning that. So this complete fragment, what it visually consists of is that single SurfaceView, and that's the one to which we'll be drawing all of those bitmaps. We're going to be doing this as fast as we can. We'll be using a thread to basically manage this process. So we're going to have, not a thread, but we're going to do this as fast as we possibly can. But we're going to have then our on resume and on pause. So we need to make sure that if we pause the activity and resume the activity, that we also go to our renderer and we get it to pause or resume itself too. We don't want it trying to draw in the background. So that's so far so good in terms of the normal setup. For the draw methods, we've got a bunch of properties here for a bitmap or paint or rectangle, the random number generator and the number of calls. These are just simply things that we use for doing our scene. And then we've got two methods, one for do setup, which creates or initialize values and loads in our bitmap, nothing fancy here. And we've got our do draw method. Now this is the one that draws the 1,000 objects. Now it will be called, what we want to be called with is a canvas object. The canvas object is fantastic. So for a canvas object, it has a bunch of methods within it for clipping different sizes, for drawing arcs, drawing bitmaps, drawing lines, drawing rectangles, drawing text, and so on. So it's a very, very useful and easy to use class whereby we can draw out our particular scene, and in this case we're using it to draw out a bunch of bitmaps. So you'll see how we get a canvas object, but this is fundamentally the mechanism whereby we will be able to determine what appears on the screen. We get the width and the height at the start, then we've got a batch size of 1,000 bitmaps, and we are iterating over that, giving each a random position and size, and drawing the bitmap out. So just a way of giving some visual variety. A little bit at the bottom, we count up the number of calls and we log that to the screen too. So this simply draws it. So much so good in terms of the setup. Now here's the renderer. This is the thing we have running as a thread where we're going to use this particular thread to draw as fast as we possibly can do. So it's not going to be as sophisticated as the game loop we saw before, so we'll have a quick look at this. So it's a SurfaceView renderer. It implements runnable, so it is something that we are going to run as a thread, and it extends SurfaceView. So a SurfaceView is a type of Android UI object, but like a text view or an image view. Here's just a surface that we get to determine what appears on that surface. Within this class, we've got our thread object will run on. We've got our usual running flag. Surface holder will come back in a second. And we've got our run method where we're going to try to do something as quick as possible. And we've got our pause and resume method. And they're the same setup as we had when we were looking at our game loops. There's no real difference there. So to a certain extent, our SurfaceView render is a very, very simple game loop. Now what do we do within it? Here's the things that are specific to that surface view. We're going to have a surface holder. A surface holder, as the name suggests, it's something that holds the surface. It controls the surface. With the surface holder, we can edit the pixels in the surface, do lots of things. We will use it really to control who gets to edit the surface. So we will lock the surface, we'll make some changes, we'll then unlock the surface. That's what you're using it for. As part of the constructor for this surface view, we say, okay, you're a surface view, you will have a holder, let me get access to it. And then within our run method, very simple, very straightforward. We've an if statement at the start where we check to see, okay, we've got a holder. Let's try to get the surface for that holder and check to see, is it valid? Now, if it's not valid, it simply means the surface hasn't yet been created. So we'll not do anything until we do have the surface. If we do have the surface, then what are we doing? We're going to the holder and we're saying, can you lock that surface, please? So we're locking the surface. We're saying nothing else should be able to write to it because we want to write to it. And when we lock it, we get out a canvas object. And using that canvas object, we will be able to draw our bitmaps. So we've got our canvas out, and we call our doDraw method, passing the canvas into it. Whenever that method returns, it will have drawn the 1,000 bitmaps. At this point, we're happy, and then we go back to our holder, and we call the unlock canvas and post method, and we pass in the canvas again. That unlocks the canvas, so it means other things can draw to that surface through the canvas. The post bit says that, okay, we've made some changes, so we should now make those changes visible. They should become visible, they should be displayed. So we're not showing the consequence of drawing those 1,000 images until after we've drawn all 1,000 of them, and that's what we want to have happen. Very simple, very straightforward. Using that, we can create a custom UI element that we can determine how it is drawn to, and we can control through, for example, a thread, how frequently we draw to it. So this works, it's lovely, it works very well. The only downside is that it's not hardware accelerated. All of the things we do there, it will be the CPU that will be drawing them. And we really want to make use of hardware acceleration. Now, just by way of a little bit of a website, if you go to developer.android.com/guide topics graphics hardware acceleration, you actually can read about hardware acceleration in Android. And where it first came in, API 11, a good time ago, some information about controlling it. There's a useful table down here which shows for a canvas what different properties are accelerated. And there's actually quite a lot of them. Drawing the bitmaps is one of the things that we will do quite a lot, and that is hardware accelerated. So there's a wide range of things that are accelerated. API 18, one of the more recent ones, we can also draw text in an accelerated way as well. But as mentioned, the one limitation here is that this applies to view objects, and a surface. Where it says a surface view is a type of view, but it's not one that is hardware accelerated. That's unfortunate, and that's the thing we want to try to improve. So we can do that, and we can do that within our canvas thread test fragment. So again, the activity class is just simply placeholder. It's the fragment that contains all of the interesting code. So let's have a look at how we can exploit the hardware renderer within Android. This class is very similar to the previous one, but there's a few important differences. So we'll do a quick scan down through it just to point out the similarities, and then we'll focus on the differences. So it's a canvas thread test fragment. We've got a canvas renderer as opposed to a SurfaceView renderer. We create the thing before, again, but we're passing in the activity, for a lot of the methods you have to give the particular context for doing graphics or canvas related ones. For us, the context is the activity to which this fragment belongs. That applies to the surface view or to this particular one as well. We've got the same resume and pause behavior. We've got exactly the same data, exactly the same setup, and exactly the same drawing mechanism. So this doesn't any way impact upon how we draw the world or the type of the type of world that we can draw. We're still getting a canvas object, so it's just a slightly different way of getting that canvas object, but it's one that we can exploit through hardware acceleration. All of the changes will be down here in this particular class. Now the interface looks similar. We've got a class name. We're not extending a surface view, we're just extending a view. So actually this is a more primitive type of class, but it's also runnable. We will have our main thread, We've got our main running flag. We've got one other flag now, a volatile flag draw needed. We'll look at that in a second. When we create it, we're doing our setup. We'll have a look at this in a second. And the pause and the resume is exactly the same as before. So the behavior when we back out our switch contacts in terms of pausing or resuming the thread is exactly the same. So most of it's the same. Now, what is different is subtle. And it can be a little bit hard to get your mind around this. In essence, what we are doing here is we are going to be using two separate threads. On the previous example for the SurfaceView, we had our SurfaceView thread, and when it was running, it simply got a lock, drew, released the lock, got a lock, drew, released the lock. Here, we're not doing that. We've got a slightly different goal. We're going to use this thread, the one that's within our canvas renderer, to actually control when something gets to be drawn, but is not going to actually do the draw. Instead, it's going to hand off to a UI thread, and all of our applications will have a UI thread that's responsible for drawing the interface, and it's going to ask the UI thread, oh, can you draw my canvas for me? And when we're drawing the canvas, we're going to be drawing the bunch of bitmaps as before. Because, and this is the reason it works, because we're going to our UI thread and asking it to draw, the UI thread is automatically, or by default, hardware accelerated. So when it's drawing out these bunch of rectangles, it will use hardware acceleration to draw them out. So they're drawing out lovely and fast. Now let's have a little look at how it does this. And we'll go down through the code in terms of the difference that we have, and then we'll maybe revisit it just once to make sure we've got the understanding of it. We've got our main run method. So whilst we're running, we're going to do the following. If a draw is needed, now this is our volatile Boolean flag. Initially it's set equal to false. Actually, when we run the thing, we set it equal to true. So it will be true whenever we begin our run. So if a draw is needed, yes. Then we set the flag to be false. So we're saying, okay, we're going to draw, and we'll set our flag to be false. So it's only going to become true after we have drawn the screen correctly. So this becomes false to indicate we haven't yet drawn it. And we call this very important method post invalidate. Now, all view objects will have a post invalidate method. They're also going to have an invalidate method too. Let me look at the text that appears for invalidate, if I can hover over it. So public void invalidate the whole view. If the view is visible, then onDraw method will be called at some point in the future. So whenever you invalidate it, you put in a request, can you draw this again, please? This must be called from a UI thread. To call from a non-UI thread, call post-invalidate. Now, this thread of control here, the one that is doing the updates, well, not updates, just doing the draws in this case, is not a UI thread. It's one we've created ourselves. So we have to call post-invalidate. Whenever we call post-invalidate, it's going to go to our UI thread and say, for this particular view, can you redraw it, please? The UI thread will go, okay, that's a request that's come in. It has a queue of these requests. And whenever it encounters this particular request, it says, okay, here I have a view. I'm going to call its onDraw method to actually draw it. And it will be the UI that will provide the canvas to the onDraw method so that it can draw itself. So the chunk of code up here, it gets to be executed by one thread of control. The code down here, it gets to be executed by a second, the UI thread, a different thread. So in essence, we have two threads that are working alongside one another. One to do the draw using hardware acceleration, and one to trigger or to request that the draw happens. Our draw needed flag is the thing that enables these two threads to communicate with each other. So we will do a draw. When we finish doing the draw, we will say we've done this, and we set our draw needed to be true. Being true will be a trigger point to enable us to say, okay, can you draw it again? And we set our flag equal to false. So you might want to think about this here, because we have two threads that are cooperating. There's a little bit of synchronization between them, so it adopts the complexity a tad, but the benefit is that by relying upon the UI thread, we get hardware acceleration, if you like, out of the box. It gives us a fairly easy way of slightly tweaking our renderer so that it is displayed much quicker, and we can use this as a stopgap until you get around to the point where you can introduce in OpenGL ES. You'll note here for you might note, for the surface view, we ran as fast as possible. Here we're not, we're actually putting in a delay of 10 milliseconds, otherwise it will run as fast as possible. And on an actual device you can try it. As mentioned here on the emulator, okay, it's a little bit flaky if you try to actually display a large number of frames per second on the emulator. So this is using the surface view. If you run the canvas test, it ticks off. Oh, no, it's paused at this point. Let's try again. So when it hopefully goes up, is much quicker using hardware acceleration, though as mentioned, the emulator doesn't really handle a very large number of frames being displayed per second, so it's better to run this in an actual device. So by way of summary, we've had a look at two different approaches that we can use. One is the basic surface view, simple, works, a little bit slow. The second one is how we can persuade the UI thread then to draw on our behalf. We get hardware acceleration, lovely and fast, but we have to deal with a little bit of thread synchronization between the two. Hopefully if you can use whatever of these you fancy by way of developing your own game. And I'll do for this particular one. One of the later demos, probably looking into next semester, we will have a look at OpenGL rendering.